Welcome back to High School Math Analyzers. Today we'll talk about functions, problem sets, part 2. You're given this function f of x equals x squared graphed below. In this problem, we have two options. It's either a horizontal translation or a vertical translation. For a graph to be a horizontal translation, it has to be moving left or right. And for a graph to be a vertical translation, it must move up or down. In order to see this, let's find the origin of our parent function, which is 0, 0. And we can see on our graph that our origin has moved down, right? And since it's moving down, that means it's a vertical translation. That is why our answer will be option B, vertical translation. In this question, we have an option of horizontal translation or reflection over the y-axis. So it means either translation or reflection. A horizontal translation means moving left or right. So let's see if it's a horizontal translation. Look at our parent function. Our origin is 0, 0. And if we look at our current function, right, our origin has moved to the left. This means it's true. It is a horizontal translation. Now let's see if it's a reflection over the y-axis. Now the reason why it's not a reflection over the y-axis is because when you plug in negative x, it maps onto itself. This is because negative x times negative x just becomes x squared. So that's why our answer would be option A, horizontal translation. In this problem, our options are either a vertical shrink or a vertical stretch. Here I've provided some graphs to show a vertical shrink and a vertical stretch. This graph is a vertical shrink, and this graph is a vertical stretch. Notice how in a vertical shrink, the new graph becomes wider, and our new graph for vertical stretch becomes thinner, right? And in our case, we can see from the parent function compared to our now function, it has become thinner, right? So thinner means that it will be a vertical stretch, which is why our answer would be option B, vertical stretch. In this problem, we have options of a horizontal shrink or horizontal stretch. A horizontal stretch is shown right here in this graph. And what we see here is a horizontal stretch means stretching this outwards. And for a horizontal shrink, it means stretching it inwards. In our case, if we compare our parent function and the function we have right now, we can see that it's a horizontal shrink because it's shrinking the parent function, which is why our answer would be option A, horizontal shrink. A chart is graph of a quadratic equation f of x equals 8 over 25x squared. Use the graph to answer the questions below. 1. To move the function up 3 units, blank. Now, this is a translation problem. This means when we're moving up, we're adding to the whole equation. What does that mean? Well, that means f of x equals 8 over 25 x squared plus 3, right? So in order to move the function up 3 units, we have to write add a 3 to the end of the equation to reflect the function over the x-axis, blank. Now this question is a reflection problem. When you're reflecting over the x-axis, that means you would multiply the entire equation by -1. So we can see that it becomes negative f of x. In this case, negative f of x will just mean -1 times h over 25 x squared. So in the blank, we will write multiply the entire equation by -1. 3. To move the function left 7 units, blank. This is a translation problem. This means that when you're translating each unit to left, it will be f of x plus h. So in our case, translate a function This means to fill in the blank, we will write add 7 to the input x before squaring. 4. To vertically shrink the function blank. In order to solve this, we must recognize that this is a dilation problem. So in order to vertically shrink a function, you must multiply the whole equation by a. Now, one limit here is that a has to be less than 1 but greater than 0. So let's write that. A has to be less than 1, greater than 0. Right? So over here, a of f of x equals h over 25 x squared. You'll multiply this by a, right? And this a has to be less than 1 and greater than 0. So we would write decrease the absolute value of a. Please subscribe. Hit the notification bell so you never miss a video. Like, comment, and share this video. Follow us on Instagram, Facebook, Twitter, and TikTok at High School Math Analyzers. Thanks for watching. We hope this video was helpful to you, and we'll see you in the next one.